Okay, this will be a video for the day 2 trig homework solutions. I'm not going to solve every problem out to completion, but I will set these problems up so you have a good idea how to go about them. So in this first one, it's asking us to find this length AB. And to do that, I need some extra information, because right now if I take this small triangle to the side and say I want to solve for this, and I know this angle is 40, well, I need another piece of information. I either need to know this side down here, or I need to know this side up here. And to figure out one of those sides, I'm going to have to go to my other triangle, so this triangle on the left, the bigger one, and say, okay, well, what can I figure out? Well, of those two sides, now I know one of them. This one's 17. I know this angle is 20, so I can use trig, right, triangle trig specifically, that I could say either I could figure out this side, or I could figure out this side. Well, which one makes the most sense? The one that makes the most sense is the one that's going to help me figure out, help me out with this triangle, and that would be this height. Now they share this same height right here, so it makes sense to find this one, because if I find this side, that means I know what this side is. So I'm going to solve for this side. I mark my angle. Opposite the 90 is the hypotenuse. This is the adjacent side, and this is the opposite side. So I care about the opposite and the hypotenuse. So if I'm looking at SOHCAHTOA, the sine, contains the opposite and the hypotenuse. So sine of 20 degrees equals the opposite over the hypotenuse. You could solve this for x, and I'll go ahead and do that. So multiply by 17 on both sides. So x is going to be equal to 17 times the sine of 20 degrees. Make sure you're in degree mode. So 17 times the sine of 20 gets you 5.814. So I now know that this length is 5.814. So if I want to solve for this side, here's your angle. Opposite the 90 is the hypotenuse. It touches the adjacent side. This is the opposite. So again, I'm going to have a sine operation. So sine of 40 degrees is going to be opposite. So the first letter, opposite, over the hypotenuse. Solve for this one. You can cross multiply or multiply by x on both sides, divide by the sine of 40, or just know our shortcut is to flip the x and the sine of 40. So x would be equal to 5.814 divided by the sine of 40 degrees, and that's something that could be done on the calculator. So that's what length AB is. Number 2 says find the volume of the cone. Again, in the top right hand corner, when you take like the air test, by the calculator, there'll be a formula sheet, or a formula button that you can look up formulas. So if you didn't know that the volume of a cone is 1/3 pi r squared times the height, they're all connected by multiplication, but 1/3 pi r squared h, then you could, look it up. You might also see it as pi r squared h divided by 3, multiplying by 1/3 and dividing by 3 is the same thing. You can see that that 3 is in the denominator, and if you think about everything being over 1, it'd still be dividing by 3. So in this problem, you have a radius, r for radius, and h for height. Well, you need to figure out the height of this cone. So if I drop down altitude, that's my height. Radius is half the circle, so conveniently I've made a right triangle. So I'm going to need two equations. One equation to figure out what the radius is, and one equation to figure out what the height is. So I'm still going to be working with this 35-degree angle that's in here. Okay. So I need to use a function that's going to relate this 35-degree angle with not only the hypotenuse, but also, say, the adjacent side, which would be r. So if I want the adjacent and the hypotenuse, that would be the cosine. So cosine of 35 degrees would equal the adjacent side, so r over the hypotenuse, 18. Multiply by 18 on both sides, and you can figure out what r is. So r is 18 times the cosine of 35. You could then, once you know r, you could do almost any function you want, but let's just say we didn't know r yet. So again, I could do this time, instead of the adjacent side, I want the opposite side to the angle. So opposite and hypotenuse, so I could do sine of 35 would be the opposite side, so h over the hypotenuse, which is 18. So this time, when I solve for h, I'll get the height of this triangle. Multiply by 18 on both sides, you get h equals 18 times the sine of 35 degrees, and you could then find the height. Once you know the height, once you know the radius, you can plug this into your Desmos or calculator. Remember when you were doing, let's see, so it's 18 sine of 35 and 18 cosine of 35. So 18 sine of 35, 18 and 18 cosine of 35. So I get my two measures. When you're plugging this on Desmos, you can type in pi, but also pi is available over here. Just be careful that you're not doing it in the denominator there. You're using this arrow key to put it to the side. So 1/3 times pi times the radius squared. So the radius was the cosine one. So 14.745. And then remember that we're doing squared, so square that value, times, and then the height, which was 10.324. And so you end up with 2350.532 centimeters cubed. All right. So the brunt of this lesson was doing problems with angle of depression, angle of elevation. What you really have to focus on is as soon as it says, like, okay, angle of depression, you're going to draw your starting point, and then you're just going to make a line going down. Because that's what depression is. It's going downhill, that ray going down, and then you have your horizontal. It'll tell you what this angle is, and that's the angle of depression. Okay? So like the angle of depression, as soon as I see the word angle of depression, I'm making a line going down, and I have this horizontal line to go with it. And I'm looking for what that particular angle is, or if I have to solve for it. So angle of depression, and it tells me is 21 degrees. So I know this is 21 degrees. Now I can go about interpreting sort of the rest of the problem and figuring out what this triangle is going to look like and what it wants me to solve for. So it says the angle of depression from a submarine to the ocean floor is 234 meters. The angle of depression from a submarine, that is 234 meters above the ocean floor. So the sub, if this is the ocean floor, that it is 234 meters. But one thing you have to be very careful of is that you are not working with this triangle. So this is not the triangle you're working with. The 21 degrees is this triangle over here. So you have to make sure that you kind of transplant stuff. If this thing going up and down is 234, then this over here is 234 meters. So just be aware of that. You could work with this triangle technically, but just realize that this isn't a 21 degree angle. If this is 21 degrees, and this whole thing would be 90, so this would end up being a 69 degree angle. And you could then work with this triangle, but typically we don't do that. We say you've drawn your line going down, make a horizontal line, that's the angle of depression. So we're working with this triangle. I know straight down from the sub's height is 234 to the floor, and then it wants me to find the distance from the submarine to the treasure chest. So from the sub to the treasure chest, so I'm looking for this hypotenuse. So setting this up, If this is my angle, opposite the 90 is the hypotenuse. This is the adjacent. This is the opposite. And I care about relating the opposite and the hypotenuse. So sine of 21 degrees. So opposite over the hypotenuse. And when I cross multiply or multiply by x on both sides and divide the sine of 21 degrees off, you'd end up with 234 divided by the sine of 21 degrees, and you could plug that in on the calculator. Okay. A support wire runs from a point on the ground to the top. Okay, if I'm going from the ground to the top, that means I'm elevating, I'm going up. So I'm going to draw a line going up, and then I make my horizontal. And whatever the angle they tell me is, I know that's the angle of elevation. So it says the wire makes a 70-degree angle with the ground. So here's your ground, the wire goes up. This must be 70 degrees. We didn't draw exactly to scale. It definitely doesn't look like a 70-degree angle, but if we really wanted to be perfect, we could redraw it. So what else? A support wire runs from the point on the ground to the top of a utility pole. So we know that there's some sort of pole here, and this is the wire. The wire makes a 70-degree angle. The length of the wire is 12 feet and 3 inches. Well, let's make this all the same units. So in 3 inches, if I do my conversion, I want inches to cancel. And I want to end up with feet because I'm talking about 12 feet. So I want some amount of feet. And that conversion is in 1 foot, there's 12 inches. So when I do 3 divided by 12, I get 0.25, and my only unit left is feet. So this is really, the length of the wire is 12.25 feet. And it wants to know the height of the utility pole. So this side, x. So here's my angle. I mark it. Adjacent side, hypotenuse, and opposite. I care about the opposite side. I care about the hypotenuse. This is going to be another sine. So sine of 70 degrees equals the opposite over the hypotenuse. Multiply by 12.25 on both sides, so that height would be 12.25 times the sine of 70 degrees. And do that on the calculator. All right, the angle of elevation. Again, as soon as I see those words, all I'm doing is I'm making some point, and I'm making a line up. That's the line that's going uphill. That's what tells me I'm elevating. And then that particular angle is when you combine that with a horizontal line, whatever this angle is right here, that's your angle of elevation. So it tells me that the angle of elevation from the top of a control tower up to a plane is 17 degrees. So this is 17 degrees, and this is from a control tower. So I have a tower, you can give it a door, and it goes up to a plane. So there's a plane up here. At that moment, the plane is at an altitude of 500 meters. So altitude just means you drop it straight down, but that means the entire height is 500 meters. So from the plane to the ground is 500. And it says, how far is the plane from the top of the control tower? So how far is this plane from the top of the control tower? And it also tells me the height of the tower is 70. So why is that important? Well, if this part is 70 right here, the height of the tower, so this is 70, then this is 70, that tells me that this side, the rest of the way for the plane, must be 430 meters. So 430 and 70 gets you to 500. So I can use that to now solve how far is this tower, the plane, from the top of that tower. So I care about my opposite side, and I care about my hypotenuse. So again, I'm going to be using sine. Sine of 17 degrees is opposite over hypotenuse. Flip the x and the sign, and your answer is 430 divided by the sine of 17 degrees. Okay, Class 2. Angle of depression. Depression means you're going downhill, so I'm just going to make a dot and go down. Then I make my horizontal, and if it gives me the angle, awesome. If not, I need to probably find it. So the angle of depression from the top of a tree. So this angle depression is from the top of a tree. So we have a tree to the top of a 12-foot pole. So I have a 12-foot pole. Is 47 degrees. So this angle of depression, that angle that's going downhill, is 47 degrees. The distance between the base of the pole and the base of the tree is 34 feet. So this distance is 34 feet. Now what that tells me is I know if this is 34 feet, then this length over here is 34 feet as well. And it says find the height of the tree. Well, if you know this piece right here is 12 feet, then once you figure out this height, this x, you'll know add 12 and whatever x is, and you'll get the height of the tree. So one thing to be careful about, again, is that you're not working with this triangle down here. I'll do that in blue. This is not what you're working with. It's tempting to say try to do something like that, but we're not working with this angle at all. So that's why it's really important to make the correct horizontal line with the angle of depression. So we're going to, so I want to, here's my angle, the sides I care about. So here's my 90. All right, I'm coming back from this video from paused and changing baby diapers. So where were we? Tree, pole, angle depression goes down, make the horizontal. Make sure that you're doing this angle and you're working with this particular triangle. So I want the, here's the hypotenuse, the adjacent. This is the opposite. So I want opposite and adjacent, so tangent of 47 degrees equals the opposite side over the adjacent side. So again, that's the TOA and SOHCAHTOA. Multiply by 34 on both sides. You get 34 times the tangent of 47 degrees. Now, whatever that is, let's actually figure that out. 34 tan of 47. 34 tan of 47. Is 36.461. 36.461. So that is just this distance right here, this x part. So I need to add 12 to that answer. So I end up with 48.461. And that would be the height of the tree. Last one, find the angle of elevation. So again, as soon as I see the word angle of elevation, I'm making a line going up, and then I'm making a horizontal. In this case, it says find the angle of elevation. So I'm going to be finding this angle, that x, right there. And it says find the elevation of the sun when a 6-foot man, so a 6-foot man. So this is 6 feet. Cast a 7-foot 6-inch shadow, so that would be 7.5 feet shadow. So again, the sun is somewhere down here, and it's casting its rays, and then the human blocks it, makes a shadow. So I care about, this is the hypotenuse, I care about the opposite side and the adjacent side. So tan of x equals TOA opposite, 6 feet over the 7.5 feet. And again, I did that, so if I had 6 inches, I want to convert that to feet. I know inches on the bottom will cancel with inches on the top, but now I've got no units. So I need to have the unit I want to end up in feet, and that particular conversion is in 1 feet, there's 12 inches. 6 divided by 12 is 0.5 feet. And then you find the angle by taking the inverse tangent over 7.5. Okay, and that's the solutions for the day